Hello, welcome back to part 9 of this tutorial series where we learn the basics of Unity and basics of Unity C# programming while also creating a pretty fun game. When we left off, we created some rules to our velocity, and that was to increase the speed to a maximum speed, which would be our 10, and how fast we change. So the maximum velocity change, if we decrease it, we can make it more like an engine where it takes a few seconds for the there we go. That's what happens when you're editing the code inside the inspector. So if we make it, let's say 0.1, we have a little different effect, and the speed takes a little bit to get going, and so on. And if we increase the speed, we can then go faster and all that cool stuff. However, one thing to notice is that when we are editing these things inside the game, when we unpause the game, it goes back to the default values. You have to be mindful of that. So if, let's say, I make this 0.1 and I really like how it looks, so I make it 0.053, and I really like how that looks, I can copy, Control-C, and then paste this here. However, I'm fine with 10 and 10 and all that fun stuff. So that being said, let's go in and add some gravity. So this won't happen right here, because it's kind of anticlimactic that I go off the ground and I'm still floating. So let's go into our code. So here we can actually now make a bool, and we have a bool for death, but we're going to make a boolean for a grounding. So bool for boolean, and we will call this grounded, lowercase g, because why not? And let's get started. So we have a start function, and that gets called in the beginning of the code. We have a fixed update function, which gets called at the default frame rate in the code. It's part of the physics engine. And we have a code, a void that we can call for physics. And some of them that we will learn will be on collision and so on. And for example, void on collision will give us on collision with an object, and the void on collision stay will make sure that there's no force applied to us, and that there is something underneath the object, like so. So on collision state is a Unity function. That means that it has magical powers within the Unity game engine. Misspelling this function will take those magical powers away. So please make sure you spell on collision state correctly. I'm a terrible speller, so I often find myself wondering why something's not working, and it's just my poor spelling. So be mindful of that and be careful. So on collision state, so if there's an object underneath us, grounded is true. Holds true. T-R-U-E. Okay. And it's saved here. And here in our fixed update, we can make grounded equals false. Now, how is that? How is that we can make void here false and here true? This one only gets called in our physics engine. This one gets only called on our state. So to show you how that works, equals false. And here I'm going to print grounded, and you don't have to print this with me. I just want to demonstrate something for you guys, because some code will have, you know, bools changing mid-code, and you're like, what's happening? And so it's false, and we're going, and we realize that as soon as I'm going to rotate down, we're off the ground. But the moment we touch that ground, we're on fire. It's changing false. It's getting checked every time. And as you see, it's doing the dance, because it's saying, "Hey man, we're there." And the reason why it's always printing false is because it's constantly changing back and forth. So there you go. Let's go back to our code and let's make the jumping feature. I'm going to take away this. Because my console is getting really messy. And after that, we can actually apply gravity. So we have gravity at 10. How do we apply gravity, guys? Well, you guessed it. We do the same exact thing by adding force. So we're adding the force of gravity, our own homemade gravity remedy. So rigid body dot add force, and open parenthesis, new vector 3. So we're making a whole new vector 3. We're not going to store or anything like that. We're doing it right inside of the function itself. So we always need a new vector 3 when creating a vector 3. And we're going to do 0, and then we're going to do gravity, and it's going to be a negative force, so we can do negative gravity, and we're going to multiply it times our mass. And what has our mass in it? It's our rigid body, because that is our physics engine. So rigid body dot mass, and then 0 here, and that will give us our gravity. So now if I hit play, and I hit save, by the way, guys, so I always save your code before going into the console, the Unity engine, and now I am surely falling. So that is pretty neat. Now we have to add our jump function. Ooh, where's my code? So our jump function would be right here. So I'm going to introduce you guys to if statements. If is a condition. If this, then that. Euler or Euler, we had the Euler rotation. Euler if then, I talked about him earlier. If what, then what. And we do this by writing if, open parenthesis, if what. If input, so if the player hits spacebar, right? Input, because the player's doing an action, get button, so we're grabbing a specific button that's in our input manager, open parenthesis, and what button? The jump button. And we then can go and add if this, then what, and how do we show then? We do brackets right here. So this is then this will happen. I'm going to hit enter. And here I'm going to add velocity. So if rigid body, if jump button is pressed, we're going to add velocity. Dot velocity. So we're not adding a specific force. We're just going to push him up as he stands. Equals new vector 3. So we're changing the y, and we can't just add this, and we're making a whole new script. So we're going to do the velocity x. So we're not going to zero this out because we might be going forward and jumping. So the current velocity of x, and I'm going to leave this blank, so I'm going to put 0, and that's where we're going to be jumping, and then the velocity of z. So we're not playing with these, they're going to stay default, so no matter what the velocity is, here, we're going to just keep it. That's why we nested velocity and velocity. As you see, we're just using the same value. But here we need to do a little calculation, and this is a perfect time to teach you how to call functions or complex floats and getters and setters and all that fun stuff. And we're going to make a float, right? And you'd be like, well, let's just put it here. Well, I actually want to make a complex float. And as we have void, which doesn't return anything, and that's what these voids mean. Void, it's blank void. It takes but never gives, right? So we're going to actually we're going to give a float. And to do that, we're going to hit enter. So right underneath our fixed update bracket, we're going to do float, and we're going to do calculate jump. And we're going to have open parenthesis, close parenthesis. This means it doesn't take anything. We don't require anything to be passed through for this to work. We're going to open close brackets, which means whatever in this bracket is related to this. You see that I have an under red line because I'm not returning a value, because again, voids don't return anything. Here we always have to return a float. And to do that, we can calculate this by doing return, or actually, let's not even do that. Let's make it, I'm going to go a longer way, but for the purpose of learning, I'm going to make a new float jump equals, and here's the math, right? So here's the calculation of the jump, and we're going to do that by grabbing the square root of our jump height and gravity, and magic is going to happen. There's a function behind it, but if we do math f dot square root, so these are, if you ever played with your TI calculator, you know how to write squirt in a calculator, because it means the same thing. Square root of 2 times, and how high we want it to jump, so we can make it 5, or we can make here, right underneath grounded, we can make a float, or actually let's keep it with above. Let's keep them all together. So I'm going to make another public float, and we're going to call it jump height. And we're going to make it equal to 2. And here, we're going to have our jump height. And we're going to multiply this times gravity that we have already nested here. So we're multiplying all this, so we're fighting off gravity, we're multiplying it times how high we want to jump, times 2. So these cancel, the gravity cancels, we go higher than that. We got the square root to make sure our object reaches this point, so this much off the ground, and that's the magic of it, right? So semicolon to end that float, and let's return that float. So we're returning return jump, and that is a float. It's not a function or anything, it's a float. Here, where we have 0, now we can call this float. And to do that, since it does return value, we can just do calculate jump, open and close parenthesis, and there you go. So that's how you do a return type. And look, the words not scare you. All we're doing is doing math in a separate little function, so it looks cleaner. We could just do this. We could copy this and paste it here. But I want to teach you guys how to use these, because these are used quite often, and when I was starting off, these things scared me. I was like, what is this, you know? When does this get called? And this doesn't get called by anything except when you call it in a function. And then it does the math inside, and then it returns a value. So I'm going to hit save. Control S, go inside of Unity, hit play. And if I didn't misspell anything when I jump, I indeed jump up to 2 points, right? So we have 7.789, and then goes to a little bit to 4, because it does that 7, 4, whatever, it adds that, and then it goes back down. So the magic there is done, and that's our player. And now we are able to start collecting coins and then creating an enemy system. So see you in part 10 of this really cool tutorial series.